Hi everyone, in this video I'm going to walk you through a complete end-to-end modern data pipeline built from scratch. We will extract real data from Gym API, load it into Amazon S3, process and transform it with using tools like Airflow, Snowflake and DBT, making it ready for the visualization and analysis. Now I will show you the workflow diagram of our ELT process. So firstly, we will extract the data from the APIs and store them in Amazon S3 bucket in the form of JSON files. And I then load them into Snowflake Data Warehouse through staging. Finally, I transform those JSON files into meaningful and structural data using DBT tool, which converts them into fact and dimensional tables. So the DBT tool is built on top of the Snowflake warehouse. So the entire process happens under Apache Airflow, where I have defined a schedule to run it on every day. Finally, I have implemented the GitHub for the version control of our DBT code. Here, we are mainly focusing on how we can create a data pipeline rather than how to visualize the things. So this is all about the data pipeline. Now I will show the APIs that I'm using for the construction of this data pipeline. These are the 4 APIs that I'm using for our data pipeline creation. So the first one is get user account details by date. So this API fetches the user account details that got created on particular date. And the next one is user personal details from date. This API fetches the user profiles that got created or updated on particular date. And similarly, the get healthy details by date. This API fetches the healthy details of the user that got created or updated on particular date. And finally, the get message details by date. This API fetches the messages or message exchange between users within the application. So these four APIs requires the parameters. So this is the parameter requirement for those APIs. We need a date parameter, that too in the form of string. So don't consider this all APIs. I just consider few of them. Like these are all the APIs that I have created for the web application using Java and Spring Boot. So don't think much about it. Like we'll stick to our subjects. So firstly, to get access to these APIs, we need to authenticate the user. For that, I have an API called login. So whenever I just click on send, it will generate some JWT token, and I copy this and paste it for the authorization of our APIs. So now we will have an access to our APIs. Then whenever the user signs in, like I just create an user with name. So the API requires an login ID, email ID, and password. Whenever I click on send, I will get a response in the form of login ID, email ID. So we haven't yet uploaded the personal details of this user, so the user hasn't been active. So similarly, the health details of the user, he hasn't uploaded his details yet. Now I will enter the details like personal profile details of the user. For that, as we have user got created with dandy at the rate 11, and I will keep the remaining as it is. So now we can see that user with an active status. Similarly, the healthy details too. I will just enter the login ID as 11, and I will keep the remaining as it is. So now we can see that user details got updated. I mean, healthy details got updated, like he has uploaded his details. And we also have an option to send the message exchange between users. So for that, I just send a message who is already in the database. So he is just asking his friend whether he is coming for gym or not, and I'll click on send. Once I click on send, I will just get a response in the form of JSON. So once we have created our basic requirements, whenever I click on the get user account details by date pro API, it requires a date parameter. I have entered the today date. It will fetches the users who got created today. So for that, whenever I click on send button, I will get a list of users who got created today. So we can see that user which we have created right back. And similarly, the user personal details from date, it fetches the user personal profile that got created on 20th. So this is how the response from the personal profile, and similarly the health details too, and finally the message exchange between users. So these four APIs are the APIs that I'm using for the construction of the data pipeline. These APIs fetches the data on particular date, so it's an and now I will create an folder on my desktop. Firstly, I will create an folder and I name it as an ETL pipe. I mean, it is an ELT pipeline, sorry. Now I open an VS Code on this directory. For that, I just open the terminal and type code dot. Here we can see that project without any basic structure. We just have a folder, but we don't have any project structure. For that, I'm going to use the Astronomer. Astronomer is a cloud tool that helps us to create a basic structure and managing the managing the Airflow project. So for that, we just open the terminal. So once I write a command astro dev initialize, it initializes the project here. So if you haven't known about the astro, we will just go on walk through astronomer documentation. So here you can see that Astro is a cloud solution that helps you focus on your data pipelines and spend less time managing Airflow. So if you haven't installed your Astro into your local system, you can just use this command brew install Astro. I think I have already installed. So I just move furtherly. So once I click on Astro Dev install, our project structure will be created here. Here we can see that our Airflow project created. Within our DAG, we can see that example DAG which we got from the inbuilt. Once I start the project, like to start the project, we just need to click the Astro Dev start. It will take few minutes to start. So our project has started in localhost 8080. So for this, we just need to enter admin. If you haven't known the credentials, you can just go back to your VS Code and you can check here. So once I sign in, so here we can see that example DAG has been created. I'm not running it right now because I don't want any information from it. You can also find your Docker images got created within your Docker. So here is the Airflow image and it is a Postgres image and the container is been running. Creating Python file under our DAG section. So the main use of this Python file is that it has to fetch the data from the APIs and dump them into our local system. I'll name it as an API to local.py and I paste the code that I have previously created and I will extend line by line. These are the packages that are required for our project and I have created the default arguments for our DAG and then I have created a DAG with a name DAG with the name daily data fetch to local and the default arguments for our DAG are these. Like the main use of these default arguments is that it tells the DAG to run one more time if it fails and I have entered the description of our DAG and then I made it to start from 20 and our project has to our DAG has to run daily. For that I just made it as a daily and then I set up catch up is equal to false because I need the data from the today itself. I mean, I don't need the data from the past. So if we want our data to be fetched from past, we have to set it as true. And I have entered the configuration settings for our project, like the base URL that we required for our project. This is the base URL that required for our project. So instead of localhost, I just entered the Docker internal because our Airflow is running in our Docker. So our Docker has to fetch the data from our localhost. So that I just provided the host as Docker file. Finally, these are the API endpoints that we are required for our project. We are fetching data from these projects. So I have made it as an keep pair value. And then I have defined the functions that are required for our project. Like first, we need to authenticate the token. For that sake, I just defined an get authenticate function. So it it verifies the username and password. Once the username and password is verified, and if we get a response type as 200, we'll get a JWT token. And I have created another function with name fetch and store, and it requires some parameters like API name, endpoint, execution date, and token. So the API name and endpoints are the key value pairs of our each API endpoint. And I have converted our JWT token into headers requirement, and I have defined an URL with the complete attributes. And finally, whenever the response is of type 200, data will be sent. I mean, data will be fetched, and then I have created a temporary directory within the directory, and I have dumped those data, into our local files. And finally, I have created a task for each API, like each API having its own task. So for that, we need an API name and endpoints as a parameter. So here execution date will be inputted by the Airflow. So we don't need to worry about the execution date. And then I have converted it into string format as our API endpoints requires date in string format. And then I have defined a token. And finally, this method will fetches and dumps our files into local system. So this is a task creation in Airflow. Each task ID will be named with API name. Finally, I have created a task dependency for each API. This is how the file looks like where the API data is fetched and moved into our local system. Now, once I save this file, I just start the project. It will take few minutes again. Now, if we go and check our localhost 8080, we'll be seeing our DAG created. Once, if I manually trigger this DAG, we can also see the logs within our DAG. So right now, our DAG is running. So we can see that we have run our DAG successfully. Here we can find our logs too. If we go and see our local system right now, so here we can see a folder with name temporary data. For each API, there will be a separate file name with date and the API name. So we can see that data has been inserted into our files. So this is how the data will be pushed into our local system. Then we'll be moving these JSON files into our S3 bucket. This is our second task. Till now we have moved our raw data from API to local system. Now we will be moving our data from local to S3 bucket. To do that, I'm just creating an AWS S3 bucket. For that, I just go to AWS console. So if you haven't created an AWS account, you can just search for an AWS free trial documentation. So here you can find the documentation. Here you can find the complete documentation on the services that AWS provides for the AWS free trial account. So as I have already created an AWS account, I'm just moving forward. So now I have to create an S3 bucket. To do that, I just click on S3 bucket. I just click on create bucket and I name my bucket as an gym data pipeline. So I leave remaining as it is. I create a bucket. So here you can see that our bucket got created. Now I have to create an IAM user for this S3 bucket. For that, I just click on IAM user and click on users, click on create user, and I name it as an Airflow user, and I click on next and click on attach policies directly, and I give full access of my S3 buckets to this user. I selected Amazon S3 full access, and I then click on next, and finally I click on create user. So here we can see that our user got created, but we need an AWS access key and the secret key of this user. To get that, click on user, click on create access key. As I need this user for the Airflow account, I just click on application running outside AWS and click on next, and I skip this for tags. Click on create user, click on download CSV. So now we have to make a connection between our AWS account and Airflow. To do that, just go back to Airflow and click on connections. So this is already a previous one. I will just get deleting this one, and I click on new connection. I name it as an AWS default, and I select AWS web services, and here we have to provide AWS key and the secret key. So we have already downloaded the key and secret key. And click on save. Once you click on save, your AWS default connection will be made. Now if you go back to VS Code, so here I just rename it as an API S3 for better understanding. So I just added additional functionality for our existing function. So here, once I save my files into local, I just move them from local to S3 bucket. For that, I just need an S3 hook connection. So I just imported the S3 hook connection. Once I made a connection to my AWS default account, here my AWS account name is AWS default. So that connection that we made in Airflow user interface. So then I loaded my files from local to S3 bucket. For that, I just need a local file path key, the key name for our folder or file, and finally the bucket where we are storing our files. So the bucket name has been defined here. I have defined the S3 bucket name as gym data pipeline, which I have already created in AWS console. Finally, I'm removing the files that are in my local. Once I loaded them to S3 bucket, I'm removing them from local. So this is all about the functionality that I have added to move our local files from local to S3 bucket. Once I have done with this, I just click on AstroDev restart. It will take few minutes to get our project started. So once our project has started, we can go to our Airflow interface. So here we can find our tag got created. So once I trigger this manually, so here we can find the logs of our DAG. So our DAG ran successfully. So here we can find the flow diagram of our DAG. So if I go back and check in my AWS S3 bucket, I have to see my files. So this is my bucket. So till now we have moved our data from API to local to Amazon S3 bucket. Now we'll be loading our data from Amazon S3 bucket to Snowflake Data Warehouse. For that, we have to create database within our Snowflake. To do that, I just open the Snowflake console. So if you haven't created a Snowflake account, you can search for a Snowflake free trial account. Here we can find that Snowflake provides 30 days free trial account with 400 credits. As I have already created it, I'm going back to my Snowflake UI console and I click on new worksheet and I paste the code that I have previously created. Firstly, I create database with name gymdb, and within my gymdb, I have to create stage that fetches the data from S3 bucket. To do that, we have to provide the URL of our S3 bucket. If you don't know the URL of S3 bucket, you can just go to here and copy the URI of your S3 bucket and paste it over here. And finally, you have to provide the credentials of your IAM user who has full access of your S3 bucket. And finally, I'm defining the file format as JSON as we are reading the JSON files. So we have successfully created our gym stage, and we have to check whether our JSON files got created within our stage or not. To do that, I just run a command list at the rate stage name. So here we can see that there are 4 files within our stage, and I'm creating a file format JSON format. And to store the data from each API, I'm creating a table for each API. Firstly, I'm creating user account details table, which holds the information about the account details. And then the user personal details. Here the user personal details has one-to-one relationship with user account details. For that, I have defined the foreign key constraint for my user account details. Similarly, the user health details too, it has one-to-one relationship with user account details. For that, I am defining the foreign key constraint. And finally, the message center. This holds the information about the messages, and it also has an one-to-one relationship with our user account details, but it has 2 foreign keys, one for the target login ID, one for the source login ID. Once we have created our database, we can check within here. So we have created our database, and we also have created our tables, but we can see that no information within our tables, and we also have an raw stage, and finally the format. Once we have done with this, we have to go back to our VS Code, and I rename our Python file as API to Snowflake as we are moving now data to Snowflake. And here, firstly, I have imported the Snowflake connector to make a connection between our Airflow and the Snowflake. And finally, within our DAG, I have written the SQL queries such that if user already exists in our database, it just updates the information, or else if user doesn't exist in our database, it creates a new row with new user login ID. So this is a copy command for user account details, and this is a copy command for user personal details, and this is for user health details. Finally, for message center. So, and we have to define a task for our Snowflake commands. For that, within our for loop, I have created a Snowflake task with different names. And here we have to define a connection with Snowflake. So we will be doing it in our Airflow interface, and our Snowflake task has to run after the API task, which means it has to run after the data got inserted into S3 bucket. So this is all about the code, and we also have to define an, we have to install the Snowflake connector. To do that, within our Docker file, I run the command pip install Apache Airflow provide the providers Snowflake, and I'm defining the version 2 to make better compatibility. Once we've written our code, we have to save it, and finally I start my project. To start my project, I just add the Astro start, and again it will take few minutes to start the project. So our project got started, and it will redirect to 8080 localhost. And before we trigger our DAG manually, we have to define the connection with our Snowflake. To do that, I just go to admin section, click on connection, and click on addition button, and I name it as a Snowflake default, and the connection type is Snowflake. And we have to write all this. We have to define a schema public, and my login name is Manjunath 528, and we have to provide the password for our your login account. And then you have to define your account name. If you don't know your account name, you can just go to Snowflake UI within admin section. You can find the accounts. Just copy the locator and paste it over here. And we just need an account name. For that, I'm removing everything. And the warehouse we are using is compute warehouse, and the database is GimDB, and the role type is account admin. Once you have defined your connection, you have to save this. So we have successfully created a connection between our Snowflake and Airflow. Now I go back to DAG section. Now I manually trigger my DAG. I go to log section. Now our DAG is running. Once our DAG successfully runs, we have to see information within our tables. So our DAG successfully ran. Now we can go to our Snowflake interface. Here we have to find the information. Here we can see that our message center got inserted, and user health details got inserted, and user personal details too. We will transform our loaded data into meaningful and structural data, like converting them into fact and dimensional tables by using the tool called DBT. For that, I'm constructing the DBT on top of Snowflake Data Warehouse, and we also need to define the separate resources for our DBT tool to do transformation. Firstly, I'm creating warehouse for our DBT. Then I'm defining the database and the role. Then we have to grant the complete usage of our warehouse and the database to our role. Then I'm gonna assign this role to my username. You can use it, you can use your own username. Using the DBT role, I'm defining the schema within our database. Then finally, we have to, by using the account admin, we have to give the complete usage of our source database called gym database to our role. To do that, firstly, we need to grant the usage of our database, and we have to give the privileges on our database and on our schema. And finally, we have to give access of our tables. So if we go back to our role, once we refresh it, here we can see that we have an access of our source database. Within our source database, we have an complete access of our tables. Now we have to move this into, like, by converting them into fact and dimensional tables into our final table within our data within DBT schema. So now we have to initialize the DBT project within our Airflow project. So to do that, if we want to include some projects into our Airflow project, we have to do within our include directory. So I just copy the file path and I open my terminal. So I will change my directory to include directory. Here we can see that we are in include directory. Now I'm initializing my DBT project. To do that, I just write the command called DBT init. So it will ask for the name of our project. I will name it as Snowflake project, and it will ask to select the type of connection. As we are making it on top of Snowflake, I'm just using the Snowflake, and it will ask for your account name. We just need to provide the value. We don't need the complete URL. So once we enter the account name, we also need to provide the username too. Then I choose through password. Then I choose the role called DBT role, on which we created earlier, and the warehouse DBT warehouse, and the database DBT transform, and then the schema DBT schema, and finally I define templates for it. So we have successfully created our DBT project within our Airflow project. Now to check whether our profile file is correct or not, we have defined our properties correctly or not, I will change my directory to .dbt, and I have to check properties within our profile file. So everything looks clean. Now I go back to my VS Code. Within our include directory, here we can see that our DBT project has started. We have installed it. Now here we can see that example SQL commands for our model. I'm gonna delete this, we don't need it anymore. So this is our project structure. Now within our model section, within our model directory, I'm gonna create a new file with name sources.yml. So here we have to define the connection with our source database called the gym database. For that, here I have named our source as raw user data and our database name as gymdb, the database which we are referencing, and finally the tables within our database. So once we have created the source, we can save it, and then we have to create stage for each table. To do that, I'm going to create separate directory. I name it as staging. So within our staging, we have to create separate stages for our tables. So I'm going to create one file with a name stage user account details .sql. Here we can see that our source is user account details table from the reference we made earlier through sources, and we are selecting all the attributes that we are needed, and we also have to do similarly for other tables, and I name it as stage personal details. So I just copy the code. So here also the same, we just made the source as our user personal details table, and we selected all the attributes, and similarly for the user health details. And finally we have to make for our message center. So we have created stages for our tables. Now we have to create, we have to do transformations on our tables, stage tables. To do that, I'm going to create one more directory within our models directory, and I name it as intermediate. So here we are transforming our stage tables into fact and dimensional tables, like converting all tables like account details, health details, and personal details into one table, and making message center as fact table. So first I'm going to create an init intermediate user profile user profiles.sql, and I copy the code. So here we can see that our sources are stage user account details, stage user personal details, and finally the stage user health details, and we are fetching all the required attributes from our stage tables. Once we are done with this, we have to save it, and similarly for the message center. And I name it as intermediate messages enriched. So here our sources are stage message center and our user account profile. And here we added additional details like a target username and the source username by using the intermediate user profiles. Once we are done with this, we have to save it. So here we have defined fact and dimensional tables. Finally, within our models, I'm going to create a final directory which stores the fact and dimensional tables, and I name it as dimensional user details dot sql, and it selects all the details from int user profiles from the intermediate table. And finally for the fact messages message details dot sql, it references the message details table from our intermediate directory. So we have made our project. To make our DBT run, we have to provide the profile file accessible for our Docker image. So firstly, I'm going to copy the profiles files into our main directory. To do that, I just write a command called copy minus r all files within our .dbt to dot, and I name our directory as dbt config. So here you can see that our profile file got copied. So and finally we have to give an access to our Docker image. To do that, within our Docker file. So before this, we have to install our dbt into our image, dbt package into our image. So then we have to copy our file from config to home as to, and I name it with .dbt. So once we are done with this, so we have to write the bash command to run our project. So our bash command is dbt run, and I name it as an dbt task id. And to run our bash command, first we have to move to our project directory, which is in our include directory. So we have to move to our Snowflake project, and then finally we have to run the our dbt project. So now we can start our project. To do that, I'm gonna do start, and it will take few minutes to run. So there was a big mistake in our copy command. Okay, I forgot to give a slash. Now we start again. So now our project is starting up. So finally our project has started in our localhost 8080. So here we can see that our DAG got created, and if I manually trigger our DAG and go into log section, here we can see that firstly it fetches the data from local to S3 bucket, and then it loads to Snowflake, and then it runs the DBT task, and finally cleans up the task. Cleans up the tables. So the graph looks like this. So our DAG runs successfully. So these were the tasks that fetches the data from local to S3 bucket, and then it loads to Snowflake Data Warehouse, and then our DBT task runs, and then cleans up the file. Those two were independent. So now if we go back to our Snowflake Data Warehouse and check our DBT transform DB, within our schema, we have to see our tables. Okay. Instead of tables, we are seeing them as a views. To make our final table as tables, and I'm gonna change it in our Snowflake. Within our project YAML file, we have to change it. So here we can see that I have materialized our marks directory into table and the staging files into views. With this, so this makes sure that our tables, whatever the tables in our marks table will be in the form of tables, and whatever the tables in our staging will be in the form of views. So this is all about the project.